Hi there, welcome back. Well, we're back to the guitar interface project for the tube radio. And since I built that first board in the previous video on this topic, I have made some changes, which is the whole idea of prototyping. Now, once again, this is a video sponsored by PCBWay. I want to thank them for their support. I'll be going back on the website, which is something I suggest you do. They get you PCBs at an incredible price, very quick turnaround time, and as I've said before and I repeat, the quality is exceptional. I have used them and will continue to use them because I find that prototyping is made simple and the result is a lot better than anything that I could do at home, which is what I used to do before I found them. So go over to the website and start doing some really great projects today. Now what we had here the first time round was a couple of changes. The board, I had made a mistake on the supply lines. That was my error. I'd used a 100K pot on the mids, which I found was a little bit high, so I changed that to a 50. Then I decided that it would not be complete without the option of a little bit of distortion, which is what you see over here. Now, again, as with most of these guitar circuits, nothing has been invented. It's all sort of redeveloped from somebody else's previous ideas. And this distortion stage is nothing more than a tube screamer. If you've been in guitar gadgets for a while, you'll know what I'm talking about. This thing produces some pretty decent distortion. You can put all sorts of options on here, but I've made it very simple. The distortion here is created by two diodes. Those guys over there, two back-to-back diodes. It's in the feedback line of the op-amp. So we're using another TL072 op-amp over here. And it creates what is called soft clipping. And the soft clipping is sort of tube-like, if you can describe it that way. It's a softer version of hard clipping. So the distortion can actually be a little bit more mellow. But you have to try it to see what I'm talking about. But I'm going to show you the circuit and the changes that I've made to the board, which I'll be ordering the second version of very soon. So here's our schematic. Now part of it looks pretty much the same as it did in the last version, with a few notable changes. Let's have a look at it one piece at a time. Power supply uses a 9-volt battery as usual. The negative of the power supply comes down here, goes to the ring of that stereo jack socket, and it will short when you put the socket in to the sleeve and make your ground. In other words, it switches on the negative of the battery and makes it ground. That's your battery switch. Other than that, what we've got here is an LED, just to give us a power on indicator. 9 volts there. The drop on an LED is about 2, so 7 volts drop across that resistor. 2.2K, it's about 3 milliamps. You could actually make it less than 3 milliamps with using one of those ultra bright LEDs, which is what we want to use here, and actually drop the current even further. 4.7 will probably work there, but we can test that later. That is our power supply. This section here is pretty much the same, exactly the same as it was before. The signal comes in here, goes through there, unity gain buffer. Now it gets to a switch. It's a double pole, double throw switch, which you can opt for the signal going into there, up, across to there, down and across, which is what it was doing before. Or, as it's switched at the moment, the signal comes in here, goes down there. When it comes back up here, it then goes through there and out that end. So we can see that we've got the addition or the inclusion of a section of circuit here, which will come in, will be kicked in when you switch down. But let's look across, as we had before, with a signal going straight through. What we have is the Fender style tone stack. The difference here will be changing the spot. Instead of a 10K linear, I've got a 25K linear. I'll probably prefer to go with a 50K analog here to give us a bit more range, but we shall see. Then the signal comes out of here, goes through this gain stage here, which is a level control. Signal comes in here, the amplification is this resistance here on the feedback path, so between there and there, which as you can see is variable from 0 to 250k. And you've got a resistor to ground, effectively, because this is a short to AC signals of 2.2. So you can actually create quite a heavy amplification here. This is what I tried in the last one. It seems to work fine, so I'll leave it like that. And then, of course, your signal goes out. That is our next stage. Now, the final stage is the one that gets switched in over here when you select the button in that direction, the switch. And this is a distortion stage, and it's a very simple distortion stage. It's actually a pretty, well, it's an exact copy really of the tube screamer pedal, which is probably one of the most famous ones around. It's been around for ages. And the signal comes in here, goes through there. Probably could have done away with the biasing circuit here and the DC blocking, but I decided to leave it like this to keep it more isolated. So the signal comes in here through that capacitor into a non-inverting op-amp circuit. The gain of this op-amp is 1 plus the resistance between there and there, between there and there, divided by the resistance between there and ground. Now, the resistance between pin 2 and ground for AC is effectively 4.7K, because this is a short to ground, with the exception of some low frequencies, but we'll call it a short to ground. And the resistance between there and there is actually the resistance that you set over here. Now, the actual tube screamer has a 47K resistor over here. I've decided to leave an X there. It's going to be placed on the board. It might be left empty, it might be shorted, because this thing gives quite a bit of gain. If you can imagine, 47K divided by 4.7 is a factor of 10, plus 1 is a factor of 11, even when this is set to 0. So a gain of 11 when this is set to 0, it means this thing goes into fuzz territory very, very fast. And I might not want that. So I actually am testing it with this thing shorted out and leaving it like that, so that this is the only resistor in the feedback loop. And we probably get a situation, we will get a situation where when I switch this on, if I have this thing set to 0, in other words, shorted over here on minimum, all I've got is a short circuit going back here. And we all know that if you have the signal coming into the positive, the non-inverting input, and if your inverting input and your output is shorted, you've got a buffer, unity gain buffer. So that's what it will be. When you set it to minimum over here, you've got a unity gain buffer. The minute you start adjusting this, the gain goes up. And as the gain goes up, at some point it gets to the breakdown voltage of these diodes, one way and the other, and this starts distorting the signal. And we will see that on the scope. It starts clipping the top and bottom of the sine waves that we'll use to test this section. Now, these diodes work or start clipping at about 0.5, 0.6. If you use different diodes, that could change. You might want to use different diodes. You might actually want to use just one, and you get a non-symmetrical clipping, because as it is here, it clips on the top and the bottom half of the waveform. But non-symmetrical clipping is actually quite interesting as well. So what I'm going to do is these 2 points, these 2 components are not going to be soldered into the board. They're drawn on the board, but there'll be probably some sort of socket where I can plug in whatever diode I want in there, or even remove it, and we can experiment with that. So that's where we stand, and then it just comes through here and goes through a unity gain buffer, back up here, and then of course it backs out, comes out again through the tone stack. So what we've got is a situation where you can either get the signal going straight through the top if you select clean, and it goes straight through just using the tone stack, which is what we had before. If you select it the other way, it'll go through the distortion section, which is that tube screamer circuit. Right, time to see this thing on the scope. I've got this set up as follows. Signals coming in here, it's just a sine wave from the signal generator. I've got the power supply feeding 9 volts in there. It's drawing just under, well, it's about 10 milliamps at the moment. So again, not much of a current draw, but remember we've got 2 op amps over here. I've got these controls all set at 12 o'clock, so they're all at 0. The gain I can increase and decrease at will. not the gain, I beg your pardon, the level. And then I've got this thing set at 0, but at the moment, let's see what happens. You see that signal there? It's about, what is it, 880? Just about 1 volt, peak to peak over there. If I take this thing and I put it to the input, 1 volt peak to peak. So with this thing at 0, I've got a unity gain. I'm putting it back to the output here. It's now effectively switched to the tube screamer. As we've seen before, if I change these guys, this is the mids, this is the treble. It does affect the overall level. The only one that doesn't really is the bass. These Fender type or Fender, Vox, Marshall type tone stacks do affect the output level. You do get gain, or rather you get attenuation. They don't stay the same. They're not active, they're passive. So they do affect your output level. You end up having to set the levels and then adjust the level, set the tone sections and then adjust the level to whatever you want. That happens on every single guitar amp that has one of these types of tone stacks. Nothing unusual there. Now, because I've got the signal coming through the tube screamer, pseudo tube screamer circuit, and I've got that resistor, that RX on the circuit set to 0, the tube screamer circuit actually has a 47K resistor on there, which immediately gives you like 12 times gain. So effectively immediate distortion. I didn't want that. You can put something in there. You can put a 4.7K, which will give you a gain of 2 straight away. As soon as you flick to distortion, it gives you a gain of 2, so it starts straight into distortion. I left that circuit, that pad on the schematic and effectively on the circuit board, on the PC board, because I want to have the option open for that. Then what we've got two 1N4148 diodes back to back there across the feedback loop of that op amp. Remember, the second op amp in that casing is just a buffer. And these two can be changed. I can remove them. I can change them for any kind of diode, germanium. I can put all sorts of diodes on here. I can actually put LEDs on there, which actually creates quite a good effect because you see it blinking as it clips. Each type of diode will have a different characteristic, distortion characteristic. And there you sort of do it to taste. And what I plan to do on the board is, instead of soldering these diodes in, I'm going to put little sockets in there, sort of single pin sockets on each end. So you can actually just plug in and plug out the diode or whatever distortion device you want to put in there. Or you can leave it out. You can make it asymmetrical by taking one off and leaving the other one in. And then you can clip the lower half of the waveform or the upper half of the waveform, whatever you prefer. I'm not going to go into which is better, because if you do that, you start an argument that has no end. I mean, guitarists are notoriously fickle about how they want their distortion, which is why this thing is left as an open-ended project. You can just tailor it to your own taste. So now, if I go and start adjusting the distortion on there, gets to a point, you see that? It starts the gain. This flickering is the pot. It's got a problem with the wiper, but you can see there, it starts the gain, and as it starts the gain, it starts clipping at the top and bottom. The waveforms are getting rounded. Now, they're not getting sharply rounded. They're actually quite smooth. Now, that's what a tube section does when it distorts. I guess that's why they call this a tube screamer. Now, if I take off one of the diodes, whoops, you see that? I've taken off that diode. Now you've got the top part of the waveform perfectly clean, and the bottom part of the waveform has started doing that clipping. And that's what asymmetrical clipping is all about. I put it back. I'll take the other one out. And now we've got the top has soft clipping and the bottom is unaffected. You put it back. Okay, there's our waveform again. Now I'm going to lower the level a little bit, just so we keep it on the screen. That's our soft clipping. That will bring in all sorts of harmonics. If I take that distortion further, it goes further and further and further to the point where it's basically getting completely clipped. I mean, this thing's going to start clipping like crazy. This thing will be almost a fuzz box when it comes out the other end. And I'm not sure that I want that much, but you know, again, this is to taste. If you want less than that, you can sort of say, okay, I want it to go that far. Measure what the resistance is on there and decide what pot you want to put on there. You could put a 250K pot. You can put a 100K pot on there if you decide that you just want sort of a slight sort of crunchy distortion as opposed to that. And that's pretty steep. But the sound starts getting interesting when you start doing this. You know, when you start getting a slight distortion and the second harmonic starts coming in just gently, that's what gives that sort of light crunch on a guitar distortion pedal. And this is what I wanted. I wanted this, this unit to be as versatile as possible. Of course, I've still got all the effect of the tone controls. You see here, I'm actually increasing the treble, and it's doing some weird stuff. So again, you get some pretty strange and interesting sounds coming on there. The level just increases the level to the point where it'll clip. Now that's a hard clip. That's the supply clip. That means that, you know, this is 5.8 volts peak to peak. That's hitting the bottom rail of the power supply. So that's no longer clipping. That's no longer distortion. That's pure clipping. And if you've got that much voltage going into your tube radio, you're going to get a hell of a fuzz. It's no longer going to be a distortion. It's going to be a fuzz. But when you're still on there, that is distortion. And that's what I wanted this pedal to do. So this is what the PC board will look like. The tone pots over here, the level, and the distortion. And then we've got that switch, that double pole, double throw switch, which is basically clean or distorted option. The LEDs over there, it shows sort of close to the board, but it's actually going to stick out, so it sticks out the top of the casing. And if we look at the other side, there are the two input and output jacks. I'm using the same ones that I've used in the test board. I've put them up for the simple reason that it's much easier to fit them into a casing. If you have them sideways, you've got to have special jacks, which you do get from Nutrix as well and from other suppliers, that fit flush, and then the outside sort of screws in. But these are much easier. They're just normal jacks. I've got my two op amps over there, some components coming through the board. I found this 3D function pretty interesting because you can actually get a good idea of what the board's going to look like. I didn't bother with some of these components down here. And those two cutouts there, I'll show you the casing in a second. That's just to make sure that this thing fits the casing properly, the enclosure. And this whole board doesn't get screwed to the enclosure because the pots actually bind the board to the enclosure. And you should then, I'll have to see about noise, but usually what you do is you take a ground connection and you attach that to the enclosure, the casing, to ground the casing to reduce noise. But you can do that pretty easily, and there's quite a few places I can connect a ground wire. And then usually what I do with these is I'll connect a ground wire to one of the ground points on there, just solder on there, bring it up and wrap it around this where it goes into the enclosure. This is the type of enclosure that I'm talking about. This ends up being the bottom. The top is there. All the pots come through there. The jacks are on this end, and everything fits in there nicely. Those two little ends that were chopped off on the board is to make sure that it doesn't affect these points. So hopefully I've measured everything well, and when it comes out, we should get something that works. As I showed you before, this is the idea. All the pots come through this end, and the jacks on that end. I considered putting a DC supply on there. We can still do that, but I don't think I'm going to bother. This thing I want to be as portable as possible, so 9-volt battery is fine, and we should have a pretty good result. So once again, thanks for watching. I'm going to order the boards from PCBWay, and as soon as they arrive, I'll do the build, do the test, get someone who actually knows how to play guitar to demonstrate it for you, and I will then be sharing the boards if they are satisfactory. I'll be sharing the boards on PCBWay's website so you can build them yourself if you choose. And the whole idea is you can actually tailor this in many ways, and I'll explain that as I build the board. If you want to change some of the characteristics for your own taste, and probably end up with a pretty interesting little project, which is useful. It makes the radios, it gives the radios a new dimension, especially if you've got a guitar lying around. Well, once again, thanks for watching. Hope you've enjoyed that. If you have, please click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Bye for now. Stay safe.